Hey everybody. Today we're graphing secant and cosecant functions. The main fact we're going to rely on is that secant of x is 1 over cosine x, and cosecant of x is 1 over sine of x. So when we graph a secant or cosecant function, we're going to start by graphing the corresponding cosine or sine function. Wherever the cosine or sine has a 0, the corresponding secant or cosecant will have a vertical asymptote. Wherever the cosine or sine has a local min, the corresponding secant or cosecant will have a local max, and conversely, wherever the cosine or sine has a local max, the corresponding secant or cosecant is going to have a local min. Let's do a simple example. Here's a graph y equals cosine of x. Let's use it to graph y equals secant of x. First of all, notice the zeros at negative 3 pi over 2, negative pi over 2, pi over 2, and so on. Those are going to be vertical asymptotes for the corresponding secant function. So I've thrown those in here. Next, notice the local extrema. The local maxes at negative 2 pi, 0, 2 pi, and so on. And the local mins at negative pi, positive pi, and so on. Let's label those with points. Those are going to be the local extrema for the corresponding secant function. Now, I'm just going to sort of connect the vertical asymptotes to those local extrema. What were local maxes for the cosine function are now local mins for the secant function, and vice versa. All right, if we want to graph more complicated secant or cosecant functions, we're going to go through a similar process. First, graph the corresponding cosine or sine function, then sort of just connect the local extrema to the vertical asymptotes. So let's briefly review how to graph a function like y equals a cosine b times x minus c, or y equals a sine b times x minus c. The amplitude is the absolute value of a. If a is less than 0, then the graph of the sine or cosine incorporates a reflection over the x-axis. The period is 2 pi over b, and the horizontal shift is c units to the right. Of course, we also need to know what the basic function y equals cosine of x looks like, and what the basic function y equals sine of x looks like. So that's something that you should also review here. Let's do a complicated example. Graph y equals 2 cosecant pi times x plus 1. So first we're going to want to graph y equals 2 sine pi times x plus 1. Let's write down some facts that we know about this graph. It's going to have amplitude 2, so that's the absolute value of the coefficient out front. It's going to have period 2 pi over b, so 2 pi over pi, or 2. And it's going to have a horizontal shift of negative 1, so that's 1 unit to the left. Let's go ahead and graph that sine function. We'll start at negative 1, 0. So starting from 0, 0 and starting from x equals 0 and moving over to the left by that horizontal shift of 1 unit to the left. Since the period is 2, the periods are going to end at 1, 3, 5, and so on. So here's what the graph looks like. Starting at negative 1, and then drawing a full period of the sine function from negative 1 to positive 1. We go up and then down, hitting the x-axis again at 0. Being negative from 0 to 1, hitting the x-axis again at 1. So a full period of this function runs from negative 1 to positive 1. Then I repeat that for every single period thereafter. From 1 to 3, from 3 to 5, and so on. Great, so there's the graph y equals 2 sine pi times x plus 1. Next, we draw in the vertical asymptotes and label the extrema, the local extrema, the maxes and mins. And then finally, graph the cosecant function, y equals 2 cosecant pi times x plus 1, by connecting those extrema with the vertical asymptotes like so. So here that graph that we needed is shown in red.